Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over the titration of a polyprotic acid. So what is a polyprotic acid, you ask? Well, let me tell you. So a polyprotic acid is an acid that has more than one proton that is going to come off in solution. So this would be acids like, for example, H2 SO4, sulfuric acid, or H3PO4, phosphoric acid. So here you have two acidic hydrogens or protons that will come off in solution. Here you have three protons or hydrogens that are going to come off in solution. So what happens when you titrate those, when you're adding, say, a strong base to titrate these polyprotic acids? And so here I have a graph of what that would look like. So here you can see that this is a diprotic acid, or Y, because you have 2 points of equivalence. So here, if you look at only this part here, you'll notice that here we start at a low pH, which is indicative of starting with an acid. And you'll see that as you add the base, the pH starts to go up, and then it comes up at this point here. And so here we have the first equivalence point, and you'll notice that I added 25 milliliters. I'm now at that equivalence point there. And so if it takes 25 milliliters to get to the first equivalence point, then it's also going to take another 25 mils to get to the second equivalence point. Well, why is that? Well, remember, if we have equal concentrations of our acid and base, and let's say we calculated the amount of volume to neutralize that first proton. There's two protons, and remember, the protons come off successively. So the first one comes off, and then the second one comes off. So here, when we're adding our base, we're neutralizing that first proton. So when we add enough of our base such that it neutralizes that first proton, it gives us our first equivalence point. So at this point right here, all of that first proton has been eliminated. So if you take this here, so here's our acid, that would be one of those hydrogens would be neutralized, but we still have one more nitrogen or one more hydrogen. So then, as soon as you reach this part here, you are now starting to remove the second hydrogen. So here you have the second hydrogen coming off, and so you reach another equivalence point when you add another 25 milliliters to reach a total of 50 milliliters, and that 25 milliliters is needed to neutralize that second hydrogen that comes off. So we get another equivalence point here, and you can see here that this point here is above a pH of 7, because at this point we have no more acid, we just have the conjugate base. So if it was H2SO4, the conjugate base would be the sulfate ion, for example. So here, then, at this point, we have the conjugate base, and so it makes sense that the pH would be above 7. Here, we have a pH that is still below 7, so it's acidic, and that makes sense because we still have an acid left here after one proton is taken off. We still have a second proton to come off. So here we have an acidic pH at the first equivalence point. And so this is the kind of graph you would expect to have for a diprotic acid. If it was a triprotic acid, then we would have 3 S curves. So here we have 2. Here's one S, and then we have a second S here. If there was 3 protons, we would expect another S curve over here. And so that's the titration of a polyprotic acid. So every time, if it takes you one volume to get to neutralize the first proton, any other successive protons, it's going to take the same volume to do each proton. So I hope this is helpful. If this helped you, please hit that like button. Also, subscribe to my channel, hit that notification bell up there, and so that way you can be notified by any other videos I put out. And also put a comment in the comment section. Let me know what you think. If you have any questions, I'd love to hear from you. Thanks for joining me. Have a great day.